Our Milky Way galaxy is a vast and complex structure, filled with billions of stars, planets, and many mysterious objects. But did you know that it also has neighboring galaxies hidden within its boundaries? Today, we're exploring two of the most fascinating examples, the Canis Major Dwarf Galaxy and the Sagittarius Dwarf Galaxy. These galaxies offer unique insights into the nature of the Milky Way and its cosmic environment. The Canis Major Dwarf Galaxy. First, let's explore the Canis Major Dwarf Galaxy. This galaxy was discovered in 2003, relatively recently in terms of astronomical discoveries. It is located about 25,000 light-years from Earth, making it one of the closest known galaxies to the Milky Way. The Canis Major Dwarf Galaxy sits in the direction of the constellation Canis Major, or the Greater Dog. This galaxy is unique because it doesn't have the familiar spiral shape seen in many galaxies. Instead, it has an irregular structure, likely due to gravitational interactions with the Milky Way. Observing the Canis Major Dwarf Galaxy is a challenge for astronomers, as it lies behind a dense field of stars in the Milky Way. Because of this, some scientists originally thought that it was part of our galaxy's outer disk. However, detailed studies have shown that Canis Major is, in fact, a separate galaxy, slowly being torn apart by the Milky Way's gravitational forces. As the Milky Way pulls on the Canis Major Dwarf Galaxy, streams of stars are drawn from it. These stars are being absorbed into our galaxy's structure, merging with existing stars and adding new material to the Milky Way's halo. The process offers a glimpse into the way larger galaxies grow by interacting with smaller ones, adding their stars in mass over time. The Sagittarius Dwarf Galaxy. Now, let's turn our attention to the Sagittarius Dwarf Galaxy. This galaxy was discovered in 1994 and is located roughly 70,000 light-years away, in the direction of the Sagittarius constellation. The Sagittarius Dwarf Galaxy orbits the Milky Way at a considerable distance but is also experiencing the effects of gravitational interaction. The shape of the Sagittarius Dwarf Galaxy is complex and has been stretched and distorted due to the gravitational forces between it and the Milky Way. Unlike Canis Major, which is very close to our galaxy, Sagittarius maintains a larger orbit. Yet, the Milky Way's powerful gravity is steadily pulling it apart, causing a stream of stars to be drawn toward us. This process of disintegration is known as tidal stripping. As the stars are pulled from the Sagittarius Dwarf Galaxy, they begin to form a structure called a stellar stream. This stream extends far from the Sagittarius Dwarf Galaxy's original center, eventually blending into the Milky Way's halo and disk. The merging stars bring unique chemical compositions, ages, and histories that enrich our galaxy with diversity. Interestingly, the stars from the Sagittarius Dwarf Galaxy have been found across a wide area of the Milky Way, forming a kind of stellar bridge between the two galaxies. Over millions of years, these stars will settle within the Milky Way, making it nearly impossible to distinguish their origins. This process highlights the dynamic nature of galaxies and how they evolve through interactions and mergers. Both the Canis Major Dwarf Galaxy and the Sagittarius Dwarf Galaxy are fascinating cases of satellite galaxies caught in the gravitational pull of the Milky Way. They provide astronomers with valuable clues about the Milky Way's past, as well as its ongoing development. The study of these galaxies reminds us that our galaxy is not an isolated island in space. Instead, it is an active participant in the cosmic dance of galaxies, constantly growing and changing. As we look to the